Erosion and sediment management, use of cross-drain culverts and offtake ditches. The intent of this video is to provide a training aid for those working in forestry and the natural resources sector in general. Funding for its development was provided through the BC Timber Sales FPInnovations membership agreement. This training aid is intended for equipment operators, construction contractors, field supervisors, environmental monitors, and planners. A key concept of this video is that water management along resource roads is critical to preventing erosion and reducing sedimentation. Water management is most important at road segments that are closer to streams or to community water intakes. 2 water management practices. The 2 water management practices that will be presented and discussed in this video are cross-drain culverts and offtake ditches, often termed culverts and offtakes for short. Cross-drain culverts are used on roads with an inside ditch to direct ditch water from one side of a road to the other. Offtake ditches, also known as ditch turnouts, are used to direct ditch water away from the road prism. A cross-drain culvert may or may not transition to an offtake ditch, but in all cases, water is ultimately directed onto the forest floor. Water management. Here is an example of impacts from a lack of water management. The arrow shows the same location in both pictures. The red dashed line highlights a large area eroded by the ditch water coming off the road. Here there was a missed opportunity to manage the water along the road before it reached the switchback. A better solution would have incorporated 1 or more cross-drain culverts and/or offtake ditches uphill of the switchback. When considering where to place cross-drain culverts and offtake ditch outlets for sediment management, this table can be a useful guide. It summarizes the amount of sediment that can be expected to reach a stream using 2 factors that together define connectivity: the distance from the outlet over the forest floor to a stream and the upslope area of disturbed drainage. Disturbed drainage area. Disturbed areas can include bare soil embankments, cut slopes, unvegetated ditch lines, and road surfaces from which sediment is readily mobilized. In this picture, we show embankment, ditch line, and road surfacing that is disturbed, as outlined in red. Further disturbed areas are upslope and not shown. The distance over the forest floor from the cross-drain outlet to the stream in the background was determined to be 50 meters, as shown with the green arrow. Water management and connectivity. While all percentages in this table are just approximations, they still provide good insight that can help guide water management near streams. As an example, consider an outlet of a culvert or offtake that is 25 meters from a stream, shown by the red arrow on the left, and has a contributing drainage area of about 400 square meters, shown by the red arrow at the top. The table shows that eventually, 20% of sediment present at the outlet may still enter the stream. Note that if an outlet of a culvert or offtake is located greater than 30 meters from a stream, the likelihood of sediment reaching an aquatic environment is estimated to be 0 for drainage areas under 2,000 square meters. Conversely, if the discharge locations are too close to the stream, such as less than 5 meters, much of the material being deposited onto the forest floor will likely resuspend and migrate over time to reach the stream. Considering how to incorporate cross-drain culverts and offtakes as part of water management applies to all phases of resource roads design life. Brief considerations will be presented in this video in terms of the associated planning, design, installation, and maintenance. Planning. When first planning a road, water management should be a primary consideration. Cross-drain culverts and offtakes should be used often. During planning, identify key areas that must have culverts or offtakes, such as long, steep road sections or switchbacks. Highlighting these areas on planned road construction maps will allow for improved communication with road builders and operators. Managing water near stream crossings may require several cross-ditch culverts and/or offtakes. This would help distribute drainage areas across the road and road prism and thereby help reduce connectivity to the stream. Spacing between structures will be determined by the slope of the road and erodibility of the soils, with steeper roads requiring more drainage. Recent findings and discussions in the field of water quality suggest that there is a general need for more cross-drain culverts and offtakes. Design. When designing culverts or offtakes, consider using construction arrangements or schematics, which would provide a clear portrayal of the final product and aid in construction. Installations require flow to have enough velocity so that any suspended sediment can be transported away from the road or ditch. Equipment operators need to make sure there is enough slope in the final product to achieve this. Construction details and techniques should be discussed with equipment operators to ensure design specifications are met. Design considerations: cross-drain culvert. Installed culvert length depends on road grade and outlet placement. Its skew is driven by road grade and may range from 25 to 45 degrees. Greater skews are required for steeper grade roads to facilitate ease of water entry into the culvert. The length of culvert should accommodate the planned skew and height of road fill and should allow for extension beyond the road shoulder. It is preferable that the outlet of the culvert is placed on natural ground rather than the fill slope. Where ditch blocks are constructed to direct flows into the culvert, use competent material to prevent its erosion. As a fail-safe for a plugged culvert, the height of the ditch block should be 30 centimeters lower than the road to allow for overtopping into the continuing ditch on the downslope side. Use appropriately sized culverts. Small diameter culverts are susceptible to plugging. To help prevent debris buildup and plugging of the culvert inlet, a minimum diameter of 300 millimeters is recommended to allow for debris passage. A bell hole, also called a catch basin, can be excavated in front of a culvert inlet to allow coarse material to settle in it. This helps lessen the amount of material entering the culvert and reduces the chances of blockage. To help address climate change and more frequent and intense storm events, even larger cross-drain culverts could be considered. For more extreme flood events, it can be challenging to determine the culvert size required for the anticipated flow volume. Cross-drain culvert locations should be designed to promote the continuation of natural water flow. They should be installed at seepage sites, either found during construction or as an upgrade once seepage is identified. If a road is built during the dry season, a thorough assessment of the road upon its first rain event is warranted. Design considerations: offtake ditch. Here are some design considerations for offtakes. Offtake ditches should be located throughout the road network to lessen the distance ditch water travels and to deliver sediment-laden water to the forest floor. Ditches should not drain directly into a stream. Strategically locate offtake ditches at the approaches to stream crossings to prevent ditch flows from delivering sediment-laden water directly to a stream. The red dashed line in the top picture indicates the location of a stream crossing in relation to the offtake. Preserving aquatic habitat is a key commitment during development and operations. Any design aid should indicate that the turn of the offtake should be gradual. A sharp angle is difficult for ditch flows to follow and may lead to erosion at the location of the sharp turn. Additional earthworks may be required to achieve adequate flow where an offtake ditch is holding ponded water. It may seem like a battle to get water to flow away from the road and stream, but a durable road and protection of water quality is worth it. Installation: cross-drain culverts. Cross-drain culverts can be placed within the excavation on native soil, and large rocks should be removed so that the culvert is not damaged. Loose and granular material is preferred for culvert bedding. The outlet must be lower than the inlet. A target grade for the culvert should be 3 to 4%, which will allow the culvert to be self-cleaning and not increase water velocity and potential for scour. Skew the culvert to allow ditch flow to easily enter the culvert, and backfill the culvert excavation with material free of large rocks, chunks of wood, or any objects which could damage the culvert. Compact the fill around the culvert, especially below the haunches. Use of a plate compactor provides excellent results. Compact in lifts no greater than 30 centimeters and alternate from side to side every 30 centimeter lift. A take-home message is that compaction is key to forming a soil arch, which provides the strength needed for the anticipated traffic. Ditch blocks should be constructed to direct ditch flow into the culvert. The material making up the ditch block, likely soil and rock, should be well compacted. The outlet of a culvert should rest on natural ground surface. Where the outlet is within the fill slope, additional armoring will be required, and depending on downhill resources, redirection of the outlet flow may be needed. High-velocity water flow can erode the soil below the culvert outlet and along the outlet flow path. Where high-volume flows are expected, or where erodible soils are present, consider armoring culvert outlets. Once outlet scour starts, erosion can accelerate and cause the road shoulder to weaken and fail. Over time, an eroded flow path due to high volume flows can take on the characteristics of a stream channel. This is often the case when there is an inadequate quantity of cross-drain culverts and too much ditch water has been directed to a singular culvert installation. Following best management practices will help ensure a successful installation. General arrangements or schematics can be developed and provided to operators to easily show the desired outcome and the best management practices to follow. These schematics for cross-drain culverts highlight the skew, ditch block, outlet location, armoring, bell hole, gradient, and extension beyond the road shoulder. Distance between culverts is identified as being site-specific. Without clear instructions and communication of best management practices, the construction outcome may not be as expected. In this picture, the placement of the boulders, possibly meant to serve as a ditch block, is not effective. Installation: offtake ditches. As mentioned within the design phase, the start of the offtake should be gradual to allow ditch water to be easily directed along the new flow path onto the forest floor. A sharp angle is difficult for ditch flows to follow without eventual erosion at the location of the sharp turn. In some cases, the sharp turn can cause deposition of material and eventual failure of the offtake. A built-up berm may be required to facilitate the gradual turn of the ditch towards the forest floor, with armoring and matting helpful in reducing ditch flow energy and erosive forces. The need for adequate water flow away from the road towards the forest floor is essential, but the exact location of an offtake is determined by site-specific topography and cannot always be precisely located in designs or plans. For this reason, best practices and general guidelines are needed for local operators to use their individual discretion. Where sites are nearly flat, use simple tools, such as a clinometer, to ensure a gradient is achieved to allow for continuous flow onto the forest floor. Additional earthworks may be required to establish the gradient needed. Ponded water along the length of an offtake is an indicator that additional earthworks are needed to create good flow towards the forest floor. Site-specific alterations may be required, such as additional earthworks to breach roadside berms and ensure a well-defined flow path. This may seem like a lot of work, but operators have shared that breaching roadside berms is easily accomplished when using the appropriate-sized excavator. If there is any level of complexity at the site, use plenty of ribbon or construction stakes to ensure the plan is communicated adequately to those doing the work. Inspection. Inspection of water management structures should be frequent to ensure the resource road continues to perform as intended. The force of flowing water and lack of water management can have severe consequences with respect to erosion and sedimentation. Planned and ad hoc inspections are both needed to ensure that culverts are not damaged or plugged and continue to function, with offtakes free-flowing and not ponding water. Areas where obvious water management is needed should be noted, such as where water has ponded, creating soft and saturated road sections. and where there have been missed opportunities to break up long distances between culverts and offtakes. The Water Quality Effectiveness Evaluation Field Protocol uses these principles and adds a few additional factors for consideration. It was developed by the Forest and Range Evaluation Program and is available as a free app download. During a site inspection, the app can help estimate sediment volumes. Knowing the volumes can help a road manager prioritize sites for remediation. Please look in the video description below for a link to the app. As discussed in the Introduction to Water Management and Connectivity, tables have been developed that define connectivity based on contributing disturbed area and distance to a stream to estimate sediment delivery. Key inputs for this calculation are length, width, and surface erosion of the contributing disturbed areas, such as road surface, ditch, or cut bank. A focus on reducing the disturbed contributing area reaching a stream crossing is good practice. This can be accomplished by using additional culverts or offtake ditches. Reducing contributing area mitigates the potential of sediment eventually reaching the stream crossing. Inspection. Connectivity check. During inspections, it is a good idea to check connectivity by getting out of the truck. Walking the outlet flow path can provide a level of certainty as to where sediment is being deposited. Where sediment has traveled further than expected, this information can be used to inform future decisions at similar sites or sites with similar soils. Should sediment be entering live streams, form a plan to direct the sediment-laden water to a more suitable deposition site. Maintenance. Water management maintenance for roads includes observing for damage and functionality of the culverts and offtakes. Culverts plugged by debris and sediment will require clearing, or if this is not feasible, replacement. When maintenance and clearing is not carried out, water can overtop or flow along the length of the culvert, ending in eventual culvert failure. Inspections can also provide insight into potential issues with the size of a culvert and the flows at the site. Evidence of high flows can often be seen along the barrel of the culvert and by deposited debris near the inlet. Where evidence of high flows have overtopped the culvert inlet, it may be an indication that a larger diameter culvert is needed or that additional maintenance was required. Damaged culverts, especially at the inlet, will not allow the anticipated flows to pass as easily, resulting in erosion and flows bypassing the culvert. These sites should be noted for culvert replacement. Ditch offtakes may show signs of hindered flow and sediment buildup. This offtake shows sediment buildup over time, as highlighted by the yellow circle. The initial turn of this offtake is likely not gradual enough and may have too flat of a gradient. Water doesn't flow uphill, and shallow grades can be difficult to discern with the naked eye. Use basic survey tools, such as a clinometer, to ensure adequate drainage. Additional earthworks may be needed to establish a slightly greater gradient. Eroded ditches and road shoulders can be an indicator of a missed opportunity for an additional culvert or offtake, or a failed culvert or ditch block. When this is observed during inspection, walking the length of road along the eroded section should help locate the source of the problem. One or more corrective items may be called for. Good mapping and site marking will ensure that corrective actions are followed through as intended. Grader berms can be left behind after a road has been graded and shaped. The berms keep road surface water from flowing into the adjacent ditch, which in turn prevents cross-drain culverts and offtake ditches from delivering ditch water onto the forest floor as planned. Because offtakes can lack definition, they can be easily overlooked by grader operators and negatively impacted by grader berms. Communication with grader operators regarding water management locations and how they function will help inform the operator and will hopefully prevent grader berms from being left behind. Grader berms need to be breached to allow water to flow off the road and into the ditch or onto the forest floor. This can be very easily accomplished with a shovel or even a boot, but is best prevented through adequate supervision and consultation with grader operators. Simple inspection and maintenance observations. Cross-drain culverts. Let's look at a few simple inspection and maintenance observations for cross-drain culverts. Typical features to look for at the site include the culvert condition, the ditch block and culvert skew, and the culvert's inlet and outlet. Assess the culvert's condition and note any damage or if the culvert is plugged. The ditch block should be intact and functioning, and the culvert should have been installed at a skew through the road. Note any debris buildup at the inlet or signs that the culvert may be undersized. When checking the outlet side of the culvert, it should not be perched or have obvious scour or erosion. Where any negative observations were made, these should be noted for continuous inspections or for corrective action. Simple inspection and maintenance observations. Offtake ditches. Offtake ditches are simpler and easier to inspect, but let's not overlook their presence. The change in direction at the start of the offtake should be gradual. A sharp turn will tend to promote scour and erosion over time. The flow should be continuous with enough grade towards the forest floor. Water ponding will create long-term issues and sediment buildup. If water flow has cut down through the native forest floor, it may be noted that subsequent armoring along the flow path could have helped. Consider armoring as a maintenance action and look for sediment buildup that can render offtake ditches ineffective. In addition, look at the inlet condition. It should be clear of blockages and have good flow throughout the length of the offtake. In summary, connectivity and proximity of cross-drain culverts and offtake ditches to live streams is a key concept to protect water quality. Cross-drain culvert and offtake ditch construction were introduced. Water management practices were described, and the importance of having adequate flow to move ditch water onto the forest floor was noted. It was emphasized that during planning and design, that more culverts and offtakes should be used for water management along resource roads. During installation, key construction methods and tools were outlined to help ensure the final desired outcome is achieved, including following best management practices. While reducing the disturbed contributing area that feeds cross-drains is important, it should be noted that additional cross-drain culverts can reduce the volume of sediment transported from one culvert to many. Managing the water is at the core of erosion control. Resources are available. 2 previous videos in this series produced with BC Timber Sales are titled Erosion and Principles of Erosion Prevention and Sediment and Principles of Sediment Control. These videos are produced with the support of BC Timber Sales and can be found on FPInnovations YouTube channel in our Resource Roads playlist. The FPInnovations guide titled Erosion and Sediment Control Practices for Forest Roads and Stream Crossings, a Practical Operations Guide, is available for free as a digital download from our website or for purchase as a hard copy from Amazon. In addition, FPInnovations has numerous research reports focusing on erosion control and water management, which can be found by searching the FPInnovations Library website. You are invited to contact us, and thank you for your time.